Okay, so to correctly answer this question, we first have to decide what distribution we should use or which formula will be used to construct the margin of error. The first thing you should notice is that the standard deviation of both populations is given right here. So that means that it's a standard normal distribution, or we can use the z distribution to construct the margin of error. You can find that by this reference page, or the one that's provided on e-learning, that says that if the population standard deviation sigma are both known, we use this formula to create the margin of error. Critical value of z times the population standard deviation squared divided by the sample size plus the second population standard deviation squared divided by that sample size. So we know we need standard normal because this critical value is a z. Then we need to find these values. So we can look up the critical value of z. I'll pull up my z table here. Critical value of z for what level of confidence? I lost it or I forgot it. 95%. So 95% means the z value is 1.96. You grab a writing. Use this guy as a scratch pad briefly. So the margin of error is the critical value of z times the square root of the standard deviation squared divided by sample size plus standard deviation squared divided by sample size. The critical value of z we just looked up, 1.96. These other values are given in the problem. Standard deviation 1 is 11.34. Population or sample size 1 was 32. Standard deviation number 2, 10.55. Sample size 2 also 32. So that will give us the margin of error. Let's calculate that over here. 1.96 times the square root of 11.34. I missed on my formula that this guy should be squared and that guy should be squared. Squared divided by 32 plus 10.55 squared divided by 32. My calculator keeps the radical, so all these numbers are under the square root, which is good. That's what the formula called for. If your calculator does not include those, you'll just want to put some extra parentheses kind of at the end here. It'll open a parenthesis. You can do the square, the divide, the add, the square, the divide, the add, or the square, the divide, and then the close the parenthesis, kind of like this. But I don't need that one because my radical is still up there. So I press enter, you get the margin of error to be 5.3665411429. The point estimate, or the best guess we have for the difference between these two means, is the difference between the sample means. In this case, that's x bar 1 minus x bar 2. So x bar 1, 70.04, x bar 2, 59, gives us a difference of 70.04 minus 59. It's 11.04. And then the confidence interval will be the 11.04 plus and minus the 5.39. So let's try 11.04 minus margin of error. And we want the same thing, but plus. Alright, so that gives me a lower bound for the confidence interval of 5.6735 to 4 decimal places, and the upper bound 16.4065 to 4 decimal places. Now, just to make sure that I made those calculations correctly, we can use the pre-built calculator function. Under tests, scroll down and find the appropriate interval to construct. We have 2 samples, and we used a z interval because it was a standard normal distribution. The population standard deviations were known. So we'll use number 9, 2 sample z interval, and enter the data or the stats from the problem. Population standard deviation 1 was 11.34. Population standard deviation 2, 10.55. Sample mean 1 was 70.04. First sample size 32. Sample mean 2 was 59. Sample size of 32, and our confidence level was 95% or 0.95. Press enter, you'll see that this matches 5.6736, so they have one little rounding error maybe in this fourth decimal place, and then 16.406 and a 5 that doesn't show up because he doesn't fit. So I'm pretty consistent or pretty comfortable with these answers. I did this problem a couple times, and the calculator answers are also accepted right in here. So if you don't do it by hand and you just were to enter 406 because that's what the calculator says, I have experienced that my TAP will accept that solution. Now, because this interval contains all positive numbers, it would lead us to believe that the first sample or population mean is larger than the second population mean because we have a positive difference when we make the subtraction between the two. So that means that if mothers are the first population, we expect their empathy scale to be higher than the fathers to create this always positive difference.